let's consider these two expressions. I almost blew the answer here. Here we want to find out whether these two expressions are derivatives or not. This is the first expression, this is the second expression. And this is quite simple because this one is the formal definition of the derivative. You start at a point, you make a small displacement, and you measure the derivative, which is you measure the slope, which is going to be in this case x plus h minus x, and then they cancel out. So this is the slope at the 2 points which are x0 plus h and x0, and h gets very small. So this way you can measure the slope. And the second one is maybe less famous, but we have also seen before. Okay, that should have been much bigger than I expected. This is how I want to do this. So I didn't spend any time writing this. I just copied it because it is something we've done already. And it will turn out that f1 and f2 are both derivatives. The reason for this is this change of perspective. So you have the derivative at, let's say you want to find the slope at x0. This is x0. If this is x0, then that is f of x0. But what if instead of adding h, instead of saying x0 plus h, why didn't we just say x? So it's another point x, which has a y-coordinate of f of x. And we measure the distance between these two, we get the change in y. And if we measure the distance between these two, we get the change in x. So the slope becomes y divided by x. Now, effectively, what's happening here is that we're, instead of writing x naught plus h, we're literally taking x and we're pushing it towards x0 or x naught. We're literally making it get closer. And so in this sense, we also get this new formulation for the derivative. And if you're confused with this, you can simply choose x to be equal to x0 plus h. You're confused, if you're not sure about the what we're doing here. So if you take x to be x0 plus h, then if h is going to 0, then x is going to x0. Okay, then this limit, instead of writing h tends to 0, we would write x tends to x0, because that's what's happening. And then f of x 0 plus h is f of x. So we just replace x0 plus h with x. And then finally, if we solve for h in this equation, we get that h is equal to x minus x naught. So it fits perfectly. It's just a u sub, or a change of perspective, more or less. U sub is a u substitution, if that is unclear. Then I just sub in h for x minus x naught, and I have my equivalent formulation of the derivative. These are two different ways we can think of derivatives of functions at a point.